Today's lesson is on logarithmic functions. Three things we'll focus on: the meaning of the word logarithm, the graphs of logarithmic functions, and some basic properties of log expressions. So a logarithm is just another name for exponent. For example, we say that 2 to the power 3 equals 8. This is a mathematical statement that describes the relationship between numbers 2, 3, and 8. One way of describing them is 3 is the exponent. We must raise the base 2 in order to obtain number 8. Now, since we said that the word logarithm is not just another name for exponent, well, we read this with the word logarithm in it. So we're going to say 3 is the logarithm. We must raise the base 2 to obtain number 8. Now I'm going to write this statement in a condensed form. So we just said that 3 is, meaning equals, the logarithm, for short we write log. We must raise the base 2, so 2 at the bottom, to obtain number 8. So we're going to say that 2 to the power 3 equals 8 is a mathematical statement that explains the relationship between 2, 3, and 8. And 3 equals log with base 2 of 8 is again a mathematical statement that explains the relationship between numbers 3, 2, and 8. So these two statements explain the same relationship in two different ways. This would be the exponential way, or exponential form, and this is what we call the logarithmic form. So as you see, there is a connection between exponential and logarithmic numbers. And we are going to practice how to convert an exponential number into a logarithmic number and vice versa. So let's practice together. I'm going to start with the first example. 5 to the power 3 equals 125. So I will start from the exponent, and I say that the exponent is 3, so I write 3 is equals the exponent, so I write log. I must raise the base 5 in order to obtain 125. If you would like to, you can pause the video and practice the rest of questions on your own. Next example. The exponent is c. So we say c is the logarithm. We must raise the base b to obtain a. Next example. The exponent is x. X is the exponent, or we say log. We must raise the base 3 to obtain y. Last example. Y equals 2 to the power of x. The exponent is x. So we say x is the exponent, or log. We must raise the base 2 to obtain y. In the next examples, we'll practice how to convert numbers from logarithmic to exponential form. So in this case, we're going to start from the base, which is down here. We're going to say that the base 3 must be raised to the power p, which is the log, or the exponent, in order to obtain 7. Next question. The base is n. N must be raised to the power of this exponent, or this log, m in order to obtain p. Last example. Base 7 must be brought to the power of 2. This represents the log or the exponent in order to obtain 49.